In 2.4, we're going to understand survey problems. We want to label sets in Venn diagrams with various names. We want to use Venn diagrams to solve survey problems. We want to understand how to handle contradictory information in survey problems. Naming Venn diagrams. We use set notation to name regions of a Venn diagram. For example, region 4 is B without A. So this region, shaded in blue, is B without A. Region 1 is A union B inverted, or A union B complement. A union B would be everything inside of A and B shaded, inside of A or B or both. But now we've shaded A union B complement. Naming Venn diagrams. Example, name R2. Well, since the book's notation is terrible for this, we will look at naming this space ourselves. We could look at it as the A without B or C. That's how I would represent it. See what the book said. The book said A intersect the B complement, intersect the C complement. So there are many ways we can describe the same set, the same region. Two different representations, one area. Area R2. Survey problems. When we collect and organize data into sets, we usually want to analyze the information. These types of problems are called survey problems. Here's a survey problem. Example, a television network conducted a market survey. The following information on viewing habits was obtained. Determine how many people do not want to see reality shows and how many prefer to watch TV on the weekend. All right, let's take a look at this problem. Okay, 3 prefer reality shows early on weekdays. 14 want to watch TV early on weekdays. 21 want to watch reality shows early. 8 want to watch reality shows on weekdays. So it looks like weekdays is a recurring theme. Reality shows is a recurring theme. 31 want to watch TV on weekdays. 36 want to watch TV early. 40 want to watch reality shows. 13 prefer late, so not early. Weekend, not weekday shows that are not reality shows. All right, so if we use a Venn diagram to help us solve this problem, we would start with 3 subsets of a universal set. These 3 subsets are reality shows, weekdays, and early. The universal set is the TV networks surveyed watchers, right? So this TV network conducted a survey. The following viewing habits, so viewers, right? So the viewers responded to this survey are the universal set U, which is represented by our box. Okay, so from you, we have people who like reality shows, people who like weekday shows, people who like early shows, and everything in between. Now, 3, we're told, prefer, get some of this out of my way. All right. Number of people who preferred reality shows early on weekends. That's the number of people who like reality shows and weekend were 3. 14 want to watch TV early on weekdays. Calling it weekends, sorry. Number of early and weekday is 14. 21 want to see reality shows early. So the number of people who want reality and early is 21. 8 want reality shows on weekdays. The number who want reality shows on weekdays is 8. That means this top clue is not that one. All right, let's reread that one then. Reality early weekdays. So the number of people who like reality and early and weekday, that's 3. That's a good clue. Good. Glad I found it. Glad we found it. 31 want to watch TV on weekdays. Number weekdays, 31. 36 want to watch TV early. So the number who want to watch TV early is 36. 40 want to see reality shows. So the number in R is 40. And we're also told that 13 prefer late, so not early, weekend, so not weekday, and not reality shows. So the number that are early or weekday or reality complement is 13. Now, some of these regions I would call freebies. So this 13 is a freebie. It's this outside area. So everything that's not in E or W or R is on this outside matted area. So H is done. Now another freebie is the 3. 3, oh, still wrote that one wrong. My goodness. Okay. The number who prefer reality and early and weekday. Their times of charm is 3. 14 want to watch TV or, oh, sorry. I start reading again. Let's see. The 3 goes here in the triple overlap. The group of people who are in the R group and the E group and the W group is this area of triple overlap, and we could call that 3. So we've used that clue as well. And those are the only clues that we can use without other information. So now I'm going to move on to 2 region territories. 14 want to watch TV early on weekdays. So E intersect W. E intersect W is this region right here, which sums to 14. Sums to 14. 3 of which is already located in the center. So the additional 11 are located here. and we've used clue B. Our overlap E is the same way. We have a sum of 21 in this region here, 3 of which is already located in the center. So we have an additional 18 so that we sum to 21 for clue C. In clue D, we're looking at the overlap of R and W, right? So the overlap of R and W sums to 8, 3 of which we already have, which means we need the remaining 5 in this location here, in this part of the region. All right, so D. Now we have used all of the 2 region clues. If you look at what we have left, we have the sum of W, the sum of E, and the sum of R. And in each of those areas, each set itself has 4 regions. So R has 4 regions. W has 4 regions. And E has 4 regions. If we look at the first clue, number E, we're told that the number in W is 31. So here are our 4 regions, and that should sum to 41. We have 8 plus 11, which is 19. So so we have 31 minus 19 is 12. We'll need 12 in this area remaining. All right, now let's take a look at the clue F, where we have the number of elements in E is 36. E is these 4 regions, 18, 11, and 3, and the 4 regions sum to 36. This is 19, 29, 30, 32. So 36 minus 32 is just a missing 4. So we have 4 in this missing region of E. Oh, took the whole kit caboodle out. There's circle around E. Okay, now he's looking pretty weak there. Now let's take a look at our last clue, which is for R, which are these 4 regions here. These 4 regions sum to 40. We have 8 plus 18, which is 26. So we have 14 remaining for R. Now let's look at answering the questions. It's always very exciting to come up with an answer, but we also have to remember it's exciting to fill in the Venn diagram, but what we always have to remember is that there were actually questions here. So let me do some erasing. And let's remember what our questions were. Okay. At the bottom, we have determine how many people did not want to see reality shows, and separately, how many prefer TV on weekends. Let's look at the first one. Determine how many people did not want to see reality shows. So if we shade every single region outside of R, we will have highlighted for ourselves the people, the viewers who did not like reality shows. So what we need to do is sum our 13, our 4, our 11, and our 12. So 13 plus 4 plus 11 plus 12 is 40. So it appears that the number of people the number of people who did not want to see reality shows is 40. And how many people prefer to watch TV on the weekend? Well, that's everyone who's not in W. So, let's see, let's highlight the area that's not in W. Okay, these are people who like to watch TV on the weekend. This time we'll sum the 14, the 18, the 4, and the 13. So 14 plus, got it too close. 14, 18, 13, and 4. We have 8 and 8 is 16, 17, 18, 19, carry the 1, 39. So here the number of people who like to watch TV on the weekends, so not the weekdays, is 39. And you can see they've started how we started. They named they used the good naming practice, right? The good naming principle in the strategy. So W for weekends, E for early programming, R for reality shows, just like we did. They set themselves up a Venn diagram. They used clue A, although their notation, that I means intersect. And they've put the 3 where W intersects R intersects E, just like we did. Now they use condition B, where they subtract from the 14 the 3 and and they have the additional 11, because 11 plus 3 is 11 plus 3 is 14. And now they've continued on with the problem, just as we have, right? These are intersections. And they got the 5 and the 18. Filling in the rest of the Venn diagram with the clues. They got the 40 and 49. So I think I summed wrong because they definitely had those numbers. I just didn't carry. So 14, 18, 13, and 4. I said 8 plus 8 is 16, 17, 18, 19. But apparently, maybe I did not carry the 1 because we got 40 and 49. All right. Sometimes you have contradictions in your survey problem. A survey problem may contain contradictory information. For example, what web browsers are used by a sample of people? 316 use WebMagic, 478 use Eyebrows, 104 use both WebMagic and Eyebrows, and 567 use only one of the web browsers. Find the inconsistency in these data. So if you, let's go back and solve it ourselves. All right, so let's take a look at this ourselves so we can really understand it. So we see that we have 2 sets in our universal set. We've got the WebMagic and the Eyebrows, right? And what else do we know? We have in clue C that 104 use both, right? So both is this section here. And we have 104 people. Okay. 104 people answered that they use both. Now we have 316 use WebMagic. So 316 minus 104 is 212. 212. We also have that 478 use Eyebrows. 478 minus the 104 in the middle is 374. And we're told 567 use only one of the web browsers. Only one. Okay, what that means, what only one means, is this group used the IB and this group used just the W, right? Because they're not in the overlap. So what we have from our Venn diagrams work is that 212 used only W, only the WebMagic, plus 374 used only the Eyebrows, which is 685, which is 586. 586 is not 567. And so they told us to find the inconsistency in the data. We found the inconsistency. There should be 586 here, according to what we've discovered. And that's what we're told here. 586 use only one of these two browsers, which contradicts D. All right, now our last two slides, we're going to look at tables. So data in tablature form, tabular form. Example, a company sells Pilates videos. How do customers wish to purchase the videos? And then we have a table here. Access code, podcast, DVD, under 41, 41 to 55, over 55. You're young for most of your life, it looks like, or a senior. Middle age is a short period of time compared to those other ones. All right, anywho, find the number of elements in M union D. M union D. Let's think about, what does that mean? M union D. So M is this group of middle-aged people who take Pilates. And D is this group of people that take and want the purchase in DVD form. Okay, so the union of these people, you would think, would be to add 86 and to add 22. But as you can see, one time when we went through the column, when we went through the row of M, we picked up this 8. And one time when we went through the row of D, we picked up this 8. And so what we need to do is we need to remove one instance of collecting the 8. So if you recall, the number of elements in MU union D is to add the number in M plus the number in D, but then to remove the instance of repetition of the intersection, the 8 being the intersection. So we want 86 plus 22 minus 8, or 100. Because 80 plus 20 is 100. 6 plus 2 is 8. Then we take away 8. So 100. Find the number of elements in not A. Let's see, where's A? Let's highlight A, right? So there's A for us. And the number of elements that are not in A, well, we could add the 63 and the 22 together, but I bet the book wants us to think about that the number of elements in A is hold on. I like this highlighter. Okay, let me switch to the pen. All right, the number of elements in A complement, right, is the number of elements in the universe that aren't in A. So here, the universal is 180. So the number of elements in U minus the number of elements in A is 180 minus 95, which is 85. Now, intuitively, we saw 63 plus 22 would also equal 85.